see here. What do we have? Check, check. All right, looks like I do have audio. A few minutes early here, guys. I'm just getting things set up. Hello, Big Stone. Thank you for waiting for me to fire this thing up. It's been a really busy morning so far, or afternoon. So I'm just trying to get things situated. I have a Riot 7500 I'm stuck on. Hopefully I'll learn something new today. Oh yes, we are gonna go over some B2s today. Well, I got this B2 here. Oh man, I see my camera. I don't want to bump the table here. I've done a couple B2s. I've done 1, 2, 3, 4. I have done 4 B2s now, and I don't know. I'm starting to get a little bit opinionated on how B2 is setting their stuff up. So we will go over some information for you guys today, in particular about how these B2s are set up. Some of you may already know that a lot of these manufacturers like to deface their ICs and put their own labels on them. So that can become a challenge. So give me just a minute here, guys, and let me finish setting up here, and we will get things going. Oh yeah, and I got a new angle on the camera here for you guys to kind of get an overview of what I'm working with here. I do have a, what is this? This is a massive audio amplifier that I think you guys are going to find quite interesting in what happened to this. So let me get things going here. We will need a scope. All right, so do we have a scope now? We do. We have a scope. Let me think here a second. There's not much I need for meter wise, so I don't think I'm gonna need a meter up, just the scope. My goal for this amplifier for you guys is to go over the layout more or less of the preamp section here, and just the amplification section, I should say, not the power supply side. From what I have found, I've been working on this B2 now for, oh gosh, since the first or second week of May. This had a very drastic failure to it. The whole output section went up, so it's been an interesting challenge to get put back together. I've gotten it to a point where I think it should be okay to fire up. As you can see, I don't have any output drive ICs in, because that's one of the items we're going to go over today. How do you differentiate what IC is used in these amplifiers? And that's kind of what I want to go over with on this board here in particular. You're going to have a few main ICs that are used in amplifiers. The SI8244 IC, which you're going to find in a lot of the Brazilian boards. The IRS 20957S is another really common drive IC, and the 2095 is another common drive IC. I think the 2095 I find in a lot of the smaller B2s. And the 2957s I find in the B2s. And the SI8244s I find in the tar amps, of course. Sound Digital uses the SI8244s. So just knowing the common drive ICs really gives you a head start on what IC to be looking for to use on a board. What's the model of the output FETs? What does it mean when the power light blinks continuously and then clip light is on? That is great. We're going to go over that, and I know exactly why it's doing that on you. So we will go over that information, but I kind of want to go in an order on this so I don't confuse anyone on what I'm trying to accomplish here. Just to let you know, the blinking power light I find is really common on the B2s and the Sound Digitals. So that's just a little heads up on that blinking light. I don't really come across that problem with the Stetson or tar amps boards. So, and it is all about design on how they are monitoring the power supply and output section. So, let's see here. So I'm just going to go over how the markings on this. So we have H1 for the power supply. Oh, sorry about that camera there. The H1s are on the power supply. Then the H1s are, I have them down as the CSD 18502 KCSs, which I do believe you could probably also use the 1404s. But I find the numbers are a little closer when you test them to the 18502s. So in my opinion, if you have a good supply of 18502s, I'd use them or the 1404s. I think the 18502s might be a little easier to drive than the 1404s, just based on some of the failures I've seen between these Brazilian style boards. And then, of course, you have your common rectifiers here. These are marked just like the Sundowns. They're S7, S8s, which I'm assuming they're probably 30 amp rectifiers. I don't know exactly what style of rectifiers they are, but I can't imagine them being much higher than 30 or 40 amps, because those are just absolutely hard to find when you start getting that high in the TO247 style packages. So the outputs are marked D1 on these, and the D1s, you're going to find that if you test the D1, a good D1, it'll come real close to an IRP4227, which again, if it goes back to like the TO220 style packages on the Brazilian boards that don't deface their ICs, you're going to find that they'd use the 4227s or the 4127s. These just happen to be in the TO247 package style, a little bit bigger wattage. So you can kind of differentiate between manufacturers, but using the same style board, Brazilian style. So again, these D1s you're going to find are the IRP4227s. The Zehners on this, if you look up the data sheets on the Zehners, you're going to find it's going to come up with two different Zehners. You're going to find a 14-volt Zehner with the same marking and a 15-volt Zehner with the same marking. At first, I don't know if I was tired or what, thinking maybe B2 did something different. I put 14-volt Zehners in. Well, don't do that. You're going to find, with my style of testing in resistance mode, that your resistance values are going to be off if you put a 14-volt Zehner in. And anyways, the common thing that they use on most all these boards are 15-volt Zehners. Which you're going to find your 15-volt Zehners at the drive ICs also right over here and right over here. and you're going to find your 15-volt Zehners across each output transistor. So this bank failed, and you can't quite see it, but it did. It burned up the paint a little bit over here. That failed, took out all the gate drive ICs, which we'll go over here in a second, and took out the main output drive IC. So, of course, it's a cascading failure on these. That usually happens. Let me get my power hooked up here. And as you can see, guys, I have mentioned this before, I use a 10 amp power supply. This board will not start with this power supply, just to let you know. I use a 10 amp power supply for most all boards that I do. And you always know ground, because ground will be screwed right to the case. But what I do like about this style of setup is you can bump the remote on this, and you'll get the preamp to start sending your signal through. This does require an input signal for the switching, which I can show you. On the scope there. It does take a second for my power supply to charge up all the capacitors. But you can see with no signal in that if you bump the remote on it, you can see on the scope there that there's nothing there. So, and I know you're probably asking, well, what pin are you on? Well, we'll go over that in just a second here, but I want to show you that this style of board does require an input signal to get the switching going. Oh, I don't have a scope. Oh, hold on, guys. Where's my scope over here? How about we get you guys a scope over this? So let's show you again here. Without that input signal, you can bump the remote, and you'll see it just jump up real quick and then go back to 0. Give it an input signal, and you will see that you have a square wave for the drive. So if you are repairing an amp and you're getting it all put together and the thing just won't have any switching signal, give it an input signal, because sometimes you do need an input signal in the preamp to get this thing to start switching for the drive ICs. So that after doing some digging around on this, trying to figure out which IC they use, because these ICs were marked C5, I started just going around each pad. Well, not really each one, because you kind of get a general idea over time of which pad will carry a signal with either 1 or 3, or it's usually between 1 and 8 on that side of the IC that has your input signals. And of course, you're gonna have your VSS or VDD, but what your primary goal is to find the pad or the pin that has your drive signal. That will tell you absolutely everything you need to know about what IC goes here. That's what tar amps uses. Yes, tar amps. If you make yourself familiar with tar amps, you will know about 90% of all other boards that are made. I love working for tar amps. They don't deface their ICs. They work with me very well. If I have questions, they get right back to me. I just love working for tar amps. Do they have some areas that could improve on design? Probably, but it has nothing to do with, how much I like working for someone. So it's not the 90 N20s. No, very few amplifiers that I know of use the 90 N20s. I do carry a few of them, and I say a few only because they're just not used commonly. And I've done some playing around with the 90 N20s with some of the 2110 or the 2113 drive ICs, and the 90 N20s are, in my opinion, hard to drive. So I'm sure I could make it easier to drive or find easier ways to drive a 90 N20, but they're just, in my opinion, tough to drive. So yeah, you'll find these D1s being a 4227, IRFP 4227 on these particular style boards. What's the rule of the transformer? What's the rule of the transformer in the amp? I asked them, what's the rule of the transformer in the amp? I'm not quite sure what the question is. What's the rule? I am not sure. You're talking about the power supply transformers? If you can kind of clarify what the question is, I can try to help explain that for you. All right, so back to where I was at. So I am on pin 3 of the drive ICs. And sure enough, the blue light's blinking, which again, we will get back to that. Pin 3 has drive on both sides. And what you're looking for is that square wave with no undershoots, overshoots, no excessive ringing or whatnot. You want a nice, good, clean square wave. So knowing that that's pin 3 and not pin 1, that's a huge difference. Pin 1 is going to be an SI8244 IC, which good luck finding them. They are difficult and very, very expensive currently right now. But you can find them. Like I said, your signal will be on pin 1 of those SI8244s. So being that this signal is on pin 3 of these C5 marked ICs, you're going to find that this is the IRS 20957 SIC. So pin 3, if you look up the data sheet on those, you will find that pin 3 is the input signal for that, and pin 1 is an input signal for the SI8244, which is two of the most, like I said, most common ICs used in Brazilian style boards. I mean, what does it do? I see there are 6 of them. Oh, what do they do? Oh, hey, great question. So let me do this real quick. Keep my fingers out of the rails here, because every time I bump it, the rail does build. So you have 8 transformers here on this amplifier. The IC, if I scoot this over right here, you have an IC right here. It's U2 marked here, U2 over here on the left hand side. That U2 drives the gates of all these transistors right along here, all these transistors. And so we got 1, 2, 3, 4, 5, 6. So 2 and 2. I'm going to say 2 and 2. 1, 2, 3, 4. Yes. So 2 and 2. So you're going to have 2 of these transistors are going to be on one winding. 2 of these transistors are going to be on the other winding. So all these do is make that transformer push and pull, push and pull. So you'll see a square wave signal coming in on the gates of these H1s. And what it's going to do is you have a drain and source here, which is going to be swinging these transformers. And then these transformers The secondary side of these transformers goes through the rectifiers, which charges your rail capacitors. So from here back is nothing but your power. So 3/4 of this amplifier is nothing but a power supply. It's a switch mode power supply is what this is. And what's the voltage? These are 200 volt rail capacitors, so you're probably upwards of 180 volts per side, I would say, on your rail voltage. So that's all this is. It's switch mode power supply. Hey, Damon. Hey, thanks for dropping in. I didn't know if I'd catch you on a Saturday or not. I have been so extremely busy. It's been crazy. So, thanks for dropping in. Where was I? Okay, so we have determined these C5s. Again, there's a marked C5 on the board or on the chip itself. The C5s you're going to find are going to be the IRS 20957S with the signal, input signal on pin 3. And then you're going to have, on this particular board, not on every board, but on this particular board, you're going to have gate drive transistors, little 6-pin gate drive transistors. I do believe they were defaced, of course. For right now, I put in the 3005s, but I do have 3003s. And if you look up the data sheets on those, you're going to find that the 3005 I think has a lower current rating than the 3003. So I see more 3005s than I do 3003s. So I'm still kind of playing around to know if that is going to be the correct drive, gate drive IC or not. I don't suspect it's going to be the 3003. These 4227s are pretty easy to drive. Now, I have not gone over the C3s, but I do suspect they are going to be the 074s, TL074. Possibly, they are definitely going to be op amps. The C4 could be equivalent to the 393 on a Brazilian board. I think that's what they are, 393s. So you're going to find that your switching on your preamp is going to come through C3, make its way to C4, then out of C4 it goes to the drive ICs. So this is kind of set up the same way as all the other Brazilian boards. It does have 3 auxiliary power supplies on this board, and you can always tell an auxiliary power supply because it's got an inductor. And then it's got a little 5-pin IC that drives a switching signal, which is going to be your auxiliary voltages. All right. So the blinking LED on these. I was working on some sound digital boards that I at first thought it had probably a bad MCU, a bad chip, because it would just blink on my 10 amp current limited power supply. Well, come to find out that these are boards you have to pulse the remote. You have to get that rail voltage to build up to a point where the MCU here determines it has enough voltage to go ahead and start up. I'm not quite ready to pulse this yet to a point to get full rail voltage, obviously because I don't have the drive ICs installed. So I literally, before I started the stream, I got the board in the heat sink, got all the old thermal paste removed and put in place, of course. Got the new thermal paste in. So I'm not quite ready to fully start this board up yet. I have a lot of work in this board, probably more than I should. But nonetheless, I do a lot of it. Sometimes I do this work just so I can take my notes and reverse engineer what they've used for future reference. So that is that. So what I'm going to do is I'm going to go ahead and I do have my 2 new ICs here. And since I have this board in front of me, I'm going to go ahead and solder these back in place. I know for sure one of the C5s were shorted. But just for good practice, I'm replacing both of the 2957s. Oh yeah, I don't even have stuff recorded, Damon. I've just been absolutely busy. I took on a a day job. I deliver parts during the day, which I'm finding is not quite working out. I just don't have enough time to get all this stuff done. So I'm probably going to be pursuing this uh, as a full time. I want to say job, full time deal. But yeah, I've got probably 20 some odd amps that are in line to be repaired. Yeah, they test your car's power to make sure there's enough to run the amp. Yeah. All right, let's see here. Let's get the ICs on real quick. Oh, hold on. One thing I forgot to mention on these boards, you're gonna find that they don't have discharge resistors. 17 volts. Like, I don't want to start soldering ICs on if there's rail voltage. So I got myself my little it's a 4.7K resistor that will discharge this rail. All right. Little flux here and there. What do we got here? The HIP40 amp is going to send you. Got it done. Oh, nice, nice. We'll probably ship you my remaining and old HIP48s to test. Excellent. Yeah. I just finished up a couple amps that used the 4080. So I had to dust off the tester. The amp that came in, sure enough, had a shorted HIP 4080. Go figure. They always short out. Yeah, they always short out. So go ahead and put my ICs on. Pin 1. So yeah, so hopefully y'all can learn something from this. Information here. I have a little note that's on the wall that has everything written down of what's what. Kind of like the D1, you know, like I said, the D1, the IRP 4227, B2s, the IRP 4115s. C5s, IRS 2957. And of course, if you have any questions, I'm more than happy to answer any questions you guys have. Let's see here. We'll probably should. Hey, Basit, how's it going? Hey, thanks for dropping in. Sorry, guys, that it's been a while since I've done any sort of videos. I just, you know, if there was more than 24 hours in a day, I could get some more videos put out for you guys. You know, it's a true fact too. If you're running a business and you're repairing amplifiers, doing videos or even live streams does make the repair take longer. So that's why I came in at the time I did today, because I needed to get some specific repairs done before I fired up the cameras. Yeah, I've done several B2s lately, and Crescendo. I've gotten a lot of larger amplifiers in. Lately, I've got two 30Ks that I just finished one yesterday or day before yesterday, and I just got another one finished up this morning. Those big old Taramp 30Ks are just, they're not my most favorite ones to repair, just due to the sheer size of them. It takes up so much space. I just don't have a lot of room to multitask with amplifiers. I can only do two 30Ks at one time. Oh, by the way, what brand is the power supply input filter caps on the B2? What brand? They are... Oh, you know, they're all faced in a way where I can't read the name. Hold on, let me see, Damon. Let me see if I can get a name here. Oh, there we are. JWFDZ. That's what brand that is. JWFDZ. What in the world is that? Yeah, I'm not quite sure. They're 25 volt. 25 volt, 4700 microfarad capacitors. JWFDZ. That's interesting. Uh, let's see here. Input cut is a B2. I have 7.9K def bounce. Same design. Yes, indeed. That I got to replace the caps on? Been seeing this a lot. You know, I don't... These are not what I would call name brand capacitors that are on this thing. They're by far something I've never even heard of. So, they're... Is it even a name? I don't know. JWFZ. Maybe if someone's bored, they can Google it real quick. It's probably just going to be another, I don't know, Chinese capacitor. Just cleaning up the flux here. You know me, I can't stand flux everywhere. Man's best friend is isopropyl alcohol and a Q-tip. Well, that's my best friend at least. The one thing I don't like about these boards is I have no way to put this thing in shutdown for me to fully really fire up the board without switching. Unless someone knows of a resistor I can pull. I mean, I'm sure I could go and pull the resistor. No, I'd rather have the IC go into shutdown. Pull the shutdown timing capacitor. I don't know. Or is that just too much work? There we go. Flux is all cleaned up. So I've been over this board several times with my checking my resistance values. Because you know me, I do things a little different. Thermal paste. God, I can't stand thermal paste. Yeah, I do things a little different than normal people. I look at resistance. And the resistance values are the same across both sides of the board, which is what I like to see. When I had the 14 volt Zeners in, my resistance values were not the same. So that's when I knew I did not get this together right. This doesn't use 14 volt Zeners. It uses 15 again. I did learn. I should stream replacing them all tonight. Yeah, you should. What's up, Todd and everyone? Hey, it's Cliff. Hey, Cliff. Yeah. How's it going? I haven't heard from you for a while. Hope things are well. I hope the family's well and everyone is safe. We did go through the old bug here right at the end of the school year for the kids. So we dealt with that. It's been an interesting month. So. All right, I got the ICs put in. I'm just going to double check that I still have a switching signal. Oops, if I put this all back together, see if I still have a switching signal going to pin 3 of these ICs. If you don't have a switching signal, then you know that something on that is dragging it down. Hold on. Hold the Pony Express. Not quite. Didn't quite get something here. I saw the glare of a pin of an IC leg, and that glare means I missed it. I went right over it. So let me catch that real quick here. There we go. All right, got it now. So, let's see. Uh, more punch. Yeah, Rockford Fosgate. I've got a rock. I got a couple of Rockford Fosgates here that driving me crazy. Still, I work there. They are stopping shift, so now I'm going to straight night shift, 11 to 7. Oh my gosh, that's not very. That's not a very friendly schedule, I guess, in my opinion. I have noticed though the warranty repairs have slowed way down for tar amps. Over this June. I don't even think I had any in May. So I've got 2 in for warranty repair for June. But I guess people are not burning up their amplifiers. Oh yeah, there we go. That's what I like to see. So a nice, and if you notice too, on that square wave, see how it's a little bit lower in amplitude, which is good. That means it is seeing. We do have an IC in place. Perfect. That's what I like to see. Is the gain up or down? So if I turn the gain up just a little bit, you should see some modulation. Oh, that gain was up. Okay. Let me. So that is 50 hertz. Nice, nice. And if I turn the gain all the way back down, there it is. Nice, perfect. Yeah. So you can see the dead time, the pulse, the width between the pulses changed with gain. So this board, once I get all these transistors nailed back down, I think this board is going to be good to fire up. I have the same values across the outputs. I'm not showing any shorts between drain and source. So this one here, I'm going to call good to put back together. I know that I am building rail. Because you can turn the power supply on. You can bump the remote a couple times. Again, I don't want to. I don't want to go too high on the rail. Yeah, there we go. Yeah. So it's building rail and it's not dropping real quick. So another thing I look for is making sure that when you're building the rail that it's not falling like a rock. Because if the rail was falling, then you know you have a short somewhere across the rail. Nice. So I don't see any shorts on that rail. So I am going to leave it at that. We took care of the question of the blue blinking light. You gotta pulse the amplifier to a point where you get enough rail voltage for the MCU to say, "Hey, let's get going." Did you get another camera or moved one? Yeah, I moved a camera. I I just have been struggling with cameras. I got another camera in, but for some reason, I just can't find one that I want to be able to place the camera away from the bench, you know, up kind of up high, but be able to zoom down and get real close and still be able to work underneath of it without having to use the microscope. So I'm trying to find a camera that's got a really good zoom on it that I can place about 3 feet above me to be able to zoom down on the board. But otherwise, yeah, cameras and me just don't get along. So I am going to move on to this board right here, because I do believe this B2 is going to be good to go back together. I did check the switching of the auxiliary power supplies, which is there. So it should be okay. So let me move on to the massive audio. All right. This is a massive audio. Oh my gosh, what do they call this thing? The P8? I don't even know what the name is of this thing. Copyright. The D, well, on the board it says D8000. It uses, what is that, 4, 8? It uses 16 640Ns. Anyone know what type of board this is? And this board here is a mess. Yeah, this board's a mess. It's gonna be kind of a tricky thing to work on because we got so much wire kind of burying everything here. But this is the good old Type 4 board. I call it Type 4. Perry calls it Type 4. I've learned it as a Type 4 board. They have used kind of a different, they just changed the layout. It's still a Type 4. They took the opto couplers, moved them on external, on daughter boards, and they took the gate drive transistors. I don't even know if this uses probably the T2 or the 1X and 2X. Let me see what ones they use here. They use 2T. Wow. Of course, I'm blind. They use the 2X and 2T transistors for the gates of those 640Ns. So this is really just a different layout of the same thing. Yes, yeah. So the opto couplers, let's see here. Gosh, yeah, see, I just despise my camera setup. So you can see the opto couplers they put on daughter boards with the transistors to drive the gates of the 640s. And then this card here has the HC74 on it. So yeah, I'm not quite sure. It's the same thing, different design. That's all really all I got to say about it. Uses it looks like a 072, of course. They're going to be using a comparator. Oh, they didn't deface these. How nice of them. Look, I can tell you real quick what these cards use. So uh, they use an LM833. That's not a 072. What did they use? So they used a 61 27 612 61724. All right, I'm gonna definitely take notes on this and have to pull up some data sheets just to see. But I'm assuming it's the same thing, an LM833 going into a 74 HC. Yep. So it's the same setup. They're just using a little different ICs. Output repaired. Yeah. For that Rockford Files Gateboard. Let's see here. Yeah, and they put the auxiliary power supplies right on the daughter board for the optocoupler. So that's how they're referencing. Yeah, it's again the same thing, Type 4, just a different layout. But this thing failed just miserably. What I found is there's a short. It looks like a piece of wire or something got across the rectifiers. Something shorted the rectifier in two different places. And I can see where it arced across. I don't think the voltage is so high on this that I would arc. There's no way. The voltage would have to be astronomical. What's the rail caps here? 100 volt. Yeah, so this is going to be your typical 78 volts or so per side. So it's definitely not from high voltage. That's from something getting underneath and touching the rectifier legs. Digging that, Todd, you might give us some sub numbers. Yeah. Yeah, very interesting setup they used on this. Have you guys looked up how much these things cost? Look at the massive audio P8. You'd be amazed at what the cost is of this Type 4 amplifier. Okay, gotta go. Birthday dinner. Yeah, oh yeah. Thanks, Damon, for dropping in. We will catch you soon again. Thank you very much. Yeah, so this has a complete shorted power supply, which is going to be obvious because the rectifier shorted out. And probably, do we suspect the outputs are bad? Huh. Well, so far, well, I'll be. So yes, so this amplifier failed from something getting underneath the board and shorting out the rectifiers, because none of the output transistors are shorted. Huh. My biggest question is, are the rectifiers damaged? So these are the 1620s. So what is that? 16 amp, 200 volt. I'm not sure. Let's see here. Do we have shorted? Well, so far I'm not showing any shorted rectifiers, so we... Oh. Oh, I was like, oh, there's a short, but that's not. No, it's... I guess the only thing really I'd have to do is repair the power supply and fire it up and see if these rectifiers survived the short. I don't know. That was a pretty good looking short here that happened. I do carry the 1620s, so it'd be no problem replacing them. Sixto, hey, it's good to see you again. Yeah, yes, I do thank you guys for dropping in and checking out the live stream here. Again, I do apologize for being absent for the last month. I will try my best to catch up on that. So, I'm gonna try my best, I should say. Yeah. So let's see here. I'm gonna go ahead and pull the no, let's see here. How am I gonna do this? I am going to well, I guess the rectifier wasn't shorted because it still had a little bit of a charge to it. So I'm just kind of reflowing the area that had the, I'm going to bet it was a piece of wire that got in between the rectifier legs. Yeah. Power supply is in pretty sad shape though. Of course, it's stacked with, these are not 3205s. Hold on. All right. So the power supply transistors in this are the IRF 1018Es. Well, do I carry those? No, I don't. So, so what we have here is we have just one, two, three. So you're gonna have 6 banks of the IRF 1018Es. I will have to look at a data sheet and see what the specifications are of those 1018s. I think, I can't remember. I looked them up. I think Mauser has those stock. Someone has them. But what I'll do is you guys can kind of get an idea of how I can just go through and pull the amplifiers apart. Burnt legs. So my goal is to see if the rectifiers are okay after I remove all this burnt stuff. Again, this is a massive audio key 8 amplifier. Type 4 for all you guys that have Perry's guide. Whew. Crispy, crispy. So these transistors will come out in pieces for you. And that's how I just go through and pull transistors. Clean up the mess, because it made a mess. Oh yeah. And then we'll just pull the other side. It's one of the first things that you do after you fix an amp is check, make sure you have drive. Which I know this doesn't have drive because the transistors that are used to drive the gates on this are burned up. So it's the same layout as all the audio pipe amplifiers that use the same Type 4 design. But this is what I do every day. Every day. So yeah, on something like this, people have to remember to, every time they use wire that they're not using ferrules with, you'll get little bits of copper that will come loose from the terminal, and it will find its way inside the amplifier, which will obviously short things out. So there's the power supply. Transistors removed. And as you can see, this board, it made a mess of the board. But it's completely repairable. There are very few boards that are not repairable. So the biggest problem right now, you see, there are all sorts of little bits of copper that have come out of this board. You can't even see it, but there is a little piece of copper strand right there on the end of my tweezers, and that little strand right there can make a whole amplifier fail. Just takes a split second for that to come across a leg of one of these transistors, or in this case, the rectifier. So right here, there was a spot where the rectifier has shorted out. Let's see here. Where are we at? Sorry. Hello. What is the guide that you just mentioned? I'd like to learn more. Oh yeah, Jesse. Perry Babin. So if you look up BACAE1, or if you just look up amplifier repair or Perry Babin, he is the guy that has put the guide together about repairing amplifiers, and it is if you were going to pursue this kind of stuff, I don't know, how should I say it, as a business, then he has a ton of information for you that will really help you understand the different topologies of these boards. I think there's 8 different topologies that he goes over and explains how they function. Let's see here. If you have to order the transistors, how do you get matched pair? Well, that's the nice thing about ordering from DigiKey, Mauser, any distributor here in the States. Again, mainly here in the States, or even LCSC. When you order a batch, I shouldn't say that. When you place an order for transistors, you usually get those transistors from a batch. They don't actually, and from what I've noticed, they don't have bins of parts that they just pull the part from. They will come in a holder, and they will all be in line with the same date code on it. So that I've never really had to worry about not getting matched components from places here in the States. Now, if you are ordering something, let's say, that is in really short supply, like these IRFP 4868s, there's been a few times where I'll get like 4 of one date and 4 of another date, or 3 and 1. It's just it's the really hard to find transistors that you're gonna probably see some discrepancy in matched pairs. I always order more than I need. That's just a rule of thumb that I have. I order more than I need to make sure that I get plenty of the same date codes and to cover any errors of installation. For instance, I just repaired a Taramps 30K. It's back here. I put it all together. It had a broken speaker terminal, so I replaced the speaker terminal on it from drop damage. I fired it up, and the dang thing blew up on me. Like, what happened? I mean, it blew up. Well, I took the whole board back out. Come to find out, I missed an insulator. So the transistor was shorted to ground when I fired it up. And luckily, I had ordered more than I needed of those transistors from a previous 30K that I did. Otherwise, I wouldn't have had enough transistors to repair my own mistake. So I always order more, and that usually gets you the same batch and date codes. But if you have to order the Mauser DigiKey, yes, same batch, yes. Yes, Cliff is absolutely correct. Hey, hold on here a second. So, uh, LCSC, and there's another one. I do use WinSource. Be prepared to pay extravagantly high prices on some stuff, though, if you have to use WinSource. They are one of my last alternative go-to people to get stuff from. Newark, I just got, well, before you notice they had more stock, I had gotten all their 24N40s at a crazy low, ridiculous price. And of course, after I bought them, they raised their price. Newark, I have gotten stuff from them. WinSource, LCSC, DigiKey, Mauser are all the common places, go-to places. I don't use DigiKey as much as I do Mauser or Arrow. I also use Arrow quite a bit too. They're all great people. So, and of course, I got to bust out my Q-tips here and the isopropyl alcohol. This amp smells like it's burned up bad. It is burned up pretty bad. You don't know what you have to do if you can't see it. So I like to make sure my area is clean. Yeah, this is going to be fun to replace the drive transistors on this, because all this wire, like why use all this wire? Oh, let's see here. I use Arrow. Yes, Arrow. Yeah, I use them all. Parts are super hard to find right now, so I go through all the manufacturer, or not all the distributors. I do have some personal sources that I also have are my go-to people. That she will pretty much find me any part that I need. Again, kind of inflated prices. I've been on, as you all know, for many months now. I've been on the hunt for the SI8244 ICs that all the tar amps uses. That my latest quote from her was $110 each. So, for all you Brazilian repair guys, if you can find the SI8244 IC for under $100, under 75, you know, share some information, because I think I'd be okay for 75 and under, but I really am not okay for paying $110 each. Hey Frank, hey, good to see you here. Thank you for joining in. If transformers are old but never used, are they still good as new, or do they age in the packaging? Oh, transistors? Oh no, they're good. I have some new old stock transistors here that are old enough where they've actually got a little, I don't want to say discolored, but you can tell by the metal that they've aged nicely. Transistors really don't age, because you gotta think and remember they're just they're solid state. They're not like the vacuum tubes that have been used in the past. They really don't wear out per se. I mean, you can heat cycle them a million times and they might wear out, but transistors that haven't been installed, I would not worry about using them. Sure are a lot of transistor guts on this board. So, if these were equivalent to the 3205s, What gate resistor value should we see here? So far, I can't see any gate resistors because they're all burned up. The pull down resistors look okay, but I'm trying to find a gate resistor value. Oh yeah, I got some. All right, what are the gate resistors on this? Just see this here. Which IC did you just mention for the SI8244BB transistor? SI8244BB is what I am after. There it is. SI8244BB transistor. Good luck. That's all I gotta say. I'm about ready to test. Once I get my test amplifier up and running, I have two SI8244 ICs right here that I paid $15 each for. I won't quite name sources yet, but if these turn out to be reliable, they're not fake, they're not rebadged, they haven't been sanded or anything. They have passed all my current tests that I know of, besides a full board test. But I did find these. We'll see how they hold up. If I can't get those ICs, it'll put a really it won't make the Brazilian boards come to a halt, but I think customers are going to be a little bit more hesitant to pay the cost of repair if I have to double the cost. So right now my charge for those ICs are $35 each. So you can kind of get an idea of why going from $35 an IC to $110 is going to be a little hard to, you know, have the customer pay for. But again, it's supply and demand of these ICs. I'm not sure if they're making them or what the deal is. I did I got 25 of the SI8244 CB or BCs from Mauser. When they had them, I got them dirt cheap, but they have a little bit lower dropout voltage. So I got to test those in a board also. Thanks for the 47, maybe 22. Yeah, Frank, I do like 10 of the... Frank, you have 10 of those SI8244s? I would, if you do Brazilian repairs, I would hold on to them with your dear life because they are super expensive. Of course, all the gate resistors are cooked to a point that I can't. Oh, 40. Oh yeah, 47 ohm. 47 ohm gate resistors. So what I do then is I just make my little note here, 47 ohm gate resistors. And these were the IRF 1018Es. For the transistors, which I'll have to pull the data sheet up and see how close they are in values to the 3205s. It uses a standard, yeah, it's a Type 4 drive. It uses the 494, goes to the typical transistors here. It's almost laid out even identical to a standard Type 4. So if the 1018 is a really close equivalent to the 3205, then I'd probably use 3205s just due to availability. What does it go in? It goes in the Brazilian boards. The SI8244s, it's your output drive ICs for the Brazilian boards. Tar amps. And Sound Digital. So I got a couple Sound Digitals here that use the SI8244s. Tarrant and Stetson. Yeah, Stetson, those guys, I don't, I'm not doing any warranty repair work for them yet, but I am working with them on different projects. So I did a sound project with them, and I'm also going to be doing I think they asked me to do a repair and resell program with them. So, yeah, if Damon, if you've got any SI8244s that you don't use or you don't think you're going to use, I will sure trade you some work for those. So what do we got here? 47 ohm gate resistors. I'm going to mark the pull down resistors because I don't want to pull them. If I can find them all. Gate, 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 gate. There it is right there. And you're going to have a pull down for each section. Gate, 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 gate. Pull down. One, two. Oh, nope. I got one more over here somewhere. Gate, 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 gate. Pull down. Gate, 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 gate. Pull down. There we go. Now I got them all. These 0805 resistors are super easy to pull off. Yeah, the cost of these boards of this particular amplifier is crazy high. For any of you guys that are familiar with the massive audio amplifiers, I don't know if for all you people that cruise eBay, but remember those amplifiers? They were like $2,700 or whatnot for their amplifiers. They're just crazy expensive amplifiers. They have quite an interesting protection circuit, though. They do have a CT here. You can't quite see it because it's buried. There's a CT here, so they are watching current by using a CT. That is impressive. I like that. Or no, let's see here. This would be overcurrent because they do have a clip light, so there's going to be a circuit here that watches for DC voltage. But I noticed they did use a CT on this. So I just use the Hakko desoldering iron here. Just puts a ton of heat on the gate resistor and slide it right off the board. We have pieces of gate resistor. That's nice. Huh. Whew. Yeah, this one failed drastically. Let's see here. Anything going on? Nope. All right. So I highly doubt that this is gonna start up because I do believe I have some bad transistors on the drive here, or what people call drive buffers. So, but it really is just your drive transistors. And I also have I have a Smart 3 and a Smart 5 that I got to get done. So if anyone is interested in knowing the layout of a Smart 3 or a Smart 5 amplifier, stay tuned for tomorrow. I do believe I have it set up for tomorrow. To repair those. Yeah, and I have a base 3K that also needs to be done. Whew. Boy, yeah, this poor amplifier has seen better days. All right. And then I'll use the desoldering gun here to remove the solder from the pads. You take the solder off the pads and all your resistors will lay flat on the board. Nice to see it. I have to go. Oh yeah, you bet, Cliff. Facing up to work. I have to go my briefly. Yeah, Cliff. Yeah, stay well out there. And again, if you have any questions, anything, feel free to give me a holler. We'll catch you on the next one and see you soon. Don't work too hard, Cliff. All right, there. The power supply is all cleaned up. Gate resistors are removed. All the burn up transistors are removed. I'm not seeing any burnt PCB, surprisingly. Let me just do some picking here real quick. No, the PCB itself didn't burn up, so no carbonized board anywhere. Which again, you know, you guys will see on the scope if you have any bad areas that have carbonized board. So yeah, the gate drive transistors are in pretty bad shape. So and they used a conformal coating. Is that conformal coating? Yeah, it kind of is. They got some of that on the transistors over here. But luckily they got hot enough where it kind of burnt the conformal coating. Yeah. So I'm probably going to leave this board as it is, and I'm gonna look up and see. I'm probably gonna bring in some of the IRF 1018Es since they were OEM on this board, and I think I'd like to keep this board OEM. This guy that sent this board in works for Massive, so I'm going to hunt down the 1018s to replace in this board. And again, you probably could use the 3205s, but if you want to stick with the the OE build, then you'd want to use the what came out of it. So I will get those ordered up because I don't carry those. And tomorrow I will be moving on to 2 tar amps boards and probably a sound digital. I have a sound digital 12K that I'm working on, so we'll get those 2 tar amps out tomorrow and the sound digital 12K and see why that thing is not starting up. It kind of has pulses in the output, so I'm thinking it could be a bad output drive IC, but again, that's the SI8244, which, hey, maybe a good time to test out the sample chips that I got here. So I do thank you guys for watching. I'm gonna go ahead and jump off. It's been an hour and 35 minutes. I don't want to make it too long and boring, but again, this is a Type 4 board, massive audio, D8000 or the D8 or P8, whichever one this is called. It's actually the P8s, the Primo series P8 amplifier that I will get the transistors ordered up for. So I do thank you guys for watching, and please like, subscribe if you like the content. If you have any questions, leave them down below there, and I will get back to you just as quick as I can. I get a lot more done with messaging than I do with actual videos, because as you can see, you really can't see, but I have amplifiers all the way down, so I just work on down the line. So it's really hard to do videos because I'm stuck in this one spot. So again, I thank you guys for watching. Have a great time. Thanks again for all the info. Yes, Jesse, again, if you have any questions, feel free to hit me up anytime down below or on my website, ellensburgamplifier.com, which, hey guys, guess what? A new site's being built right now, which is almost done. I think you guys, if that are familiar with my current site, are going to love the new site. So I've gotten to a point where I know the website is very critical to the success of the business. So I have hired someone to design a new website. What's this? What's this? Massive. What is this? Come on, guys. Well, I'm gluing that down. So yeah, thanks guys. I will catch you on the next one. Leave those comments down below. Like and subscribe. We'll see you soon.